And now let's talk about characters animations. Um, as you can see, the character has 7 animations, and in order to activate them, and they're activated in different states. So there is a idle state, and the idle animation is played. So the player just stands normally, it's called happy idle state, like happy idle animation. Then there is a happy walk animation, where player just walks forwards. And there is a running animation where player runs forwards. Oh yeah, I forgot to turn our smooth camera on from previous video. All right. In order to run, you press Shift and running activate W and Shift, and running activate an animation is activated, and you're running. You're moving faster than you used to be with walking. Then there is a going backwards animation. You just press S, and if you press Shift and S, you have this running backwards animation. Then there is a turning right animation and turning left animation, and you've got to press D and A in order to activate them. And yeah, of course, you can run right, left, right, left. Yeah. So the character's movements and activation of animation was achieved via finite state machine. The character control was achieved via finite state machine and various states. So let's talk about smoothing those animation, like blending them together. Like, for example, if there wasn't any blending, then those animations wouldn't look as smooth as they look now. So let's talk about this blending stuff on the example of 1 second. So yeah, let's talk about this blending stuff on the example of walking and running state. So there we walk and we start running. We walk, we press shift, kind of accelerate there to run. Here we can see the code that kind of does the blending. So first, if previous state was walking or running backwards, but in this case walking, we find a ratio of the current action, which is running, and the previous action, which is walking. Yeah, and the ratio means the duration of those 2 clips, and we try to start the running animation from a position. So yeah, we find this ratio, the duration of those 2 clips, by dividing the current action duration by the previous action duration, and then we multiply the time, the previous action when it exited the previous state, and multiplying it by this ratio to find a starting time of the current action. So yes, to find a timestamp in the animation where the current action should start to translate from the previous action, to smoothly translate from previous action. So yeah, so it basically kind of finds the approximate starting position of the animation. I hope I explained it right. I mean, I hope I explained it right. I hope I explained it so you did understand it. So, and let's see the difference with the smoothing algorithm and without the smoothing algorithm, the blending algorithm, or it's also called crossfade. Yes, it's called crossfade. All right, let's see. So, as you can see, the running animation doesn't start as smooth as it used to start with this kind of blending slash smoothing algorithm. All right. I think that's it for characters animations, and see you later. And yeah, it was mentioned that this kind of control, though, this kind of smoothing is done for every transition between animations. So turning right, walking backwards, flying backwards, and so on. All right. See you in the next video.